Hello everyone, in this video we're gonna be looking at the physical quantities. Alright, so let's just start here. What are physical quantities? If I could see that the quantities the quantities that can be measured. First of all, we need to clear what are the physical quantities. The quantities that can be measured are known as the physical quantities. Then we have the physical quantities division. According to what? According to some conditions. So we're gonna see that as well. So the physical quantities are divided into two sections. Alright. Number one is scalar and number two is vector. As I told you, the physical quantities are the quantities that can be measured, measurable quantities. Alright, so those measurable quantities are now divided into another stuff, and that is known as scalar and vector. Let's just see what is scalar. The quantities that have certain number and magnitude. Certain number and magnitude, are the same. Magnitude, I'm really sorry for the distraction. Let's just begin. The quantity that have certain number and magnitude and have unit are known as vector quantities. Alright, I hope you got this right. Now we're gonna see the example. The quantity that have certain number or magnitude. What does mean by this? Can you please say? It can be 3, it can be 4, it can be 5, right? And a unit, we know that we have measuring unit, meters, centimeters, kilometer. All right, so the quantity, for example, 3 meter. All right, 3 meter, we have the quantity 3 meter. Now 3 meter have the certain number. We can verify it have a certain number. All right, this is a certain number and it have a unit as well. So that is why this is known as a scalar quantity. If I could give you the example of the scalar quantity, so it can be, let me just raise it for it. The scalar quantities can be mass. Does mass have any direction? No, exactly, it does not have any direction. All right, and we have temperature. Does temperature goes to east, west, north, south? No, it is not goes. Then we have energy. All right, and many more examples. All right, so these were the quantities. Now if we could look up the examples or the vector quantities, then what are those? What are vector quantities? I'm sorry, the quantities which have certain number and have unit and direction. All right, so here the word, the another word comes that is for direction. All right, here direction comes. So what does mean by this direction? If I could ask you to go straight, and to go 3 meters straight, right, and pick my shoes, will you be able to pick the shoes? Exactly not. Till that, if I won't give you any direction, go straight to the north, go straight to the south, go straight to the west, to the east, so it won't make sense. So the quantities that have particularly direction and have a certain number. For example, if I could give you the example, it's exactly when I see the example as well. So example, 3 meter in north, all right, 5 meter to east, all right. These are the example. And if we look at the physical quantities that have, that those are vector, so it can be weight, weight is a vector quantity. Why? Because weight have the direction. You might be thinking, what kind of direction does weight possess? Because we know that weight is the acceleration due to gravity, and the gravity direction is always downward, so always the weight have the direction. All right, then we have force. Yes, exactly, force have the direction. अगर मैं आपको बोलूँ कि you have to apply force in there, like there, at this wall, at that wall, so I'm giving you the direction. All right, then we have a velocity, meter per second, right? The unit is meter per second. Velocity, किस स्पीड, किस वेलोसिटी में जा रही है? द कार इज़ गोइंग विद दिस वेलोसिटी. Velocity requires, direction. Then we have acceleration. Acceleration also requires, and the formula, unit of acceleration, meter per second, is square. All right. So if I could ask you that, can you please elaborate what is current? Current, like current have the direction. How current have the direction? I'm gonna say that here. I'm gonna say it's kind of current. All right, current have direction. How current have direction? Can you say? Yes, exactly, because flow of electron, we say flow of electron is known as current. So it current we know by this definition, we knew that current have the direction. Flow हो रहा है तो it must be in some direction, right? 5 ampere. So here we have the unit and the magnitude as well. But here, if I could tell you that the vector quantities are the quantities that have the direction, plus they obey the rule of vector addition. Okay, I hope that makes sense. So vector quantities are the quantity that obeys the rule of vector addition. But here, in this case, direction is required, direction is present, flow of electron, and we have the unit as well. But here, why don't we call it as a vector quantity? Because it does not obey the rule of vector addition. All right, so we got to learn 3 things about vector. It has direction, obeys the rule of the vector addition, and have magnitude as well. All right, I hope you're clear. And new thing is that this current can be a tensor quantity. All right, it can be a tensor quantity as well. So if I could give you the example of current, let me just make it more clear. This is 5 ampere, this is 4 ampere. 5 plus 4 is equal to 9 ampere, right? But the direction of the current is here, right? So that is why it does not follow the rule of vector addition. I hope my students you got this. Now we're gonna see the representation of vector, that how can we represent the vector. All right, so we're gonna see how the vector is represented. All right, I hope dear that is clear. Now we're gonna see how vector is, I'm so sorry, yes, exactly. So this is, now I'm gonna make an arrow, right? This is an arrow, okay? This part of the arrow is known as tail, okay? Basically this tail part shows the length, all right? You need to remember. And this part that gives the arrow head, that head, this is known as head. And what's the purpose of the head? Head gives you the direction. All right, head gives the direction. You can easily see, it's common sense that this is a line and it is heading towards, it's giving direction toward this. All right, so that is why this is the representation of the vector. Now we're gonna see in more ways how can we represent vector. This is the representation of vector as well. We can represent the vector as well. All right, and in this way, sorry, a vector modulus. This way we can represent the vector as well as the direction. But this, if I talk about this modulus, so at this modulus, these two brackets are known as modulus, that we usually study in mathematics. You can say mod as well, and the formula of that is under root x square plus y square. It's just an extra info, you can note it down. So these mode is used for what? Magnitude. All right, magnitude. So I hope that is clear. Now we're gonna see few directions. All right, I'm gonna make a chart over here. So now I'm gonna make, as I promised, here we know that this is north, south, east, and we have, sorry, this is west. This is west and that's east. So now you need to think before going down. If I am making the angle over here, what will be the direction of this angle? Can you name it? Can you name it? Yes, exactly. It is in north, south. If I'm making the angle over here, can you name the direction of the angle? This is in north, west. If I'm making the angle over here, that is in south, west. If I'm making the angle over here, that is in south, and this is east. I'm sorry. And that is east as well. Alright, northeast, northeast, northwest, southwest, and southeast. Alright, this was the direction that we can publish, or like we can rectify by the north, east, west. I hope that is clear. In next video we're gonna be understanding about the types of the vector. We have position vector, unit vector, parallel vector, anti-parallel vector, null vector. So we're gonna be looking at them as well. Till that, goodbye.